In this problem, we're given a function. P is a function of t, which is this linear equation here, and we're asked to find the inverse function. Getting the answer to this problem usually requires about 5 seconds of students doing work. The difficulty is students don't know what to do with the problem, so most of this video will be me explaining the meaning of this question. The actual doing the question will take about 10 seconds if I was just to do it. So for example, in current condition, we have p as a function of t, which implies since t is in the parentheses, it's the input, and capital P is the output. So this is a little bit different than a traditional math problem in that in a story problem context, these variables might have meaning. So for example, if I assign some meaning to this where t is time and p is, say, some population of some city, that's not in the problem. Let me just impose that scenario. This would be the story behind this is that in current condition, someone would be plugging in t would be my input. So we'd be plugging in a time value, and the idea is that population would be my output. So suppose somebody wanted the inverse of that. Suppose we wanted t to be the output and p to be the input. How would we accomplish that? So if I wanted this reverse, all I end up doing is solving this for whatever the current input is. In this case, it's t. So it turns out doing this problem is as simple as solving for t, and students take about 10 seconds doing that, and that would look like this. To solve for t, I would first probably add the 5 over, so you'd have p plus 5 over here, and then on the right hand side, a negative 5 plus 5 would be 0, so I don't need to write plus 0. And then since the negative 4 is being multiplied, the correct inverse operator would be to divide. And we often see these cancel, but if you want, they really simplify to be 1. So often we say, well, these cancel. What really happens is a number divided by itself is 1, so you really have 1t. But we just tend not to write 1 times t. Instead, we just write t. So it gives the appearance that they just disappear. So at any rate, I've accomplished my goal. Again, that could be done in probably about 10 seconds. I don't think any of my students would get this wrong if I said here's an equation, solve for t. It's as simple as adding 5 and then dividing by negative 4. The issue is that the notation is so foreboding that students don't know what to do. So if you look at what we started with and what we end with, the idea is that the meaning of the variables have not changed. In the original problem, t was time and p was population, and that's the same as the meaning down here. Nothing's changed. The only thing that's changed is the arbitrary assignment of which variable is the input and which is the output. So where I had t as an input now, I'm now regarding time as the output, and where population was my output, I'm now regarding p as the input. T still means time, p means population, nothing's changed. It's just what we define to be the input and the output has changed. So the notation is as follows. If I was to write this equation down and leave a spot from here to write the function notation, I have no choice how to label this function. The rule is if the original function was named f, which is right here, and you find the inverse function, then the notation is to put a little -1 up here. And it looks like an exponent, but trust me, this just means this is part of the name, f raised to the -1, or however you state that. This whole thing is just now the name of the function. There's nothing being raised to the -1 power at all. And then the rule is whatever's in the parentheses is the input here, and I'm considering p as my input, so I have to put a capital P here. So if you just look at the original statement and look at what we were supposed to find, t equals f inverse of p, it's just sort of a confusing notation, but reality, all it is the t and the p got swapped. So to switch them, you simply solve for the input variable. It's always the way with an application problem. So it's just as simple as I could redo the problem in 10 seconds. There was a p on the left-hand side. I would be solving for t. I would do that by adding 5, and then subsequently after adding 5 over, you would divide the -4. So hopefully that cleared some things up.